In this problem, we need to solve for x. You want to make sure that your radical is always isolated as much as possible. Once it is, we are going to square both sides. When we square both sides, on the left side, the square and the square root cancel, and we're left with just that 3x plus 7. On the right side, make sure that you FOIL it out. What do we get when we FOIL that out? Sorry, you're thinking, write it twice and multiply. So 3x times 3x is 9x squared. 3x times 5 is 15x. Another 15x is 30x. And then 5 times 5 is 25. Now from here, we're going to subtract our 3x and our 7. With a quadratic, we want to factor it and have this equal to 0. So now we have equals 0, 9x squared plus 27x plus 18. Now, in this problem, we could probably factor a GCF. Our GCF is 9. And when we factor that 9 out, we have x squared plus 3x plus 2, which makes it a lot easier to factor. If we want to continue factoring, we will be asking ourselves, what multiplies to 2 and adds to 3? And that is going to be 2 and 1. So when we solve to find out what x is, we don't need to worry about this 9 because there's no variable with it to solve for. And so we end up with -2 and -1. Now remember, because it's a square root and even index, we need to double check and make sure two things. One, that we don't have a negative under the square root, and also that it's not equal to a negative outside. So if I plug in the -2 that we get, if I plug in this -2, we're multiplying, we would end up on the left side with -6 plus 7, and that is the square root of 1, which is 1. But on the other side, we have 3 times -2 is -6, plus 5 is -1. And that does not work. So we're going to cross off the -2. Now let's try our -1. If I replace my x's with -1 and multiplying them, let's see what we get. 3 times -1 is -3, plus 7 is 4, square root of 4 is 2. 3 times -1 is -3, plus 5 is 2, and it works. So our only answer is x equals -1.